Hello students, today's agenda is to check homework. We'll be doing even and odd functions and you will be able to do 5.4. Today students will be able to determine whether functions are even or odd. And before we start, I'm going to show you some graphs. We've seen this topic a little bit before about odd and even functions. And so a function is even if the y-axis is the line of symmetry, meaning that if you fold this graph in half, this part of the graph will meet with this half. If you fold it in here, this half is going to meet with this half. Okay, so they match, and the same here. So that means it's even. The function for that is f of negative x equals f of x. And I know you don't know what that means maybe right now, but we'll go to it. For an odd function, it means that it has a 180 rotation and you match. So basically, this is the graph. If you rotate it 180 degrees, meaning upside down, you still get the same thing. And if you notice for this one, again, if you rotate it 180 degrees, you still get the same graph, and the same for this. Okay, so you might want to try it. If you can see, okay, you get the same thing. Okay, that's what it means for an odd. If you remember from before, it means double flip. Okay, if you fold it in here, this comes here, but then you fold it again and this becomes this. So that's another way of noticing. For odd functions, algebraically, it's f of negative x equals negative f of x. Okay, so that's important. That's what we're going to be using, because now we're not going to be working with the graphs. We're going to be working with the formulas. Okay, and sometimes you will have some of the graphs that are neither, because in here, if you fold it, this part doesn't match with anything in here. If you fold it in here, this part is not going to match with this. It's going to go over here, so it doesn't match. And so if you fold it, this is not going to match. This big part is not going to match this little part. Okay, so that will be that it's not even. It's neither odd nor even. Okay. Okay, so let's begin with the functions. With the formulas, I'm sorry. For an even, you need f of negative x equal to f of x. And for the odd, it has to be f of negative x equals negative f of x. And you will see what that means in a minute. So let's begin with the first example. So if I have the original function, which is f of x equals 2x plus 3, that this expression is f of x, okay, and I am writing it in brown, so to help it identify. And so the next part, I'm gonna use green for the the function of negative x. So f of negative x, what this means is don't write x in here, replace it with negative x. Okay, so every negative and every x is going to be replaced with negative x. It's going to be the 2, I replace the negative x, and plus 3. So in here, positive 2 times negative x is negative 2x. And then you just bring down the 3. So to know if this function is even, you say, is the f of negative x, meaning this answer, equal to f of x, meaning this? Are they the same? Well, no, because this is positive and this is negative. So no, it's not even. So now I'm going to proceed to find the negative f of x. Okay, why? Because since it's not even, now I'm gonna go and see if it's odd. And it means that f of negative x, meaning this answer, f of negative x, this answer has to be equal to negative f of x, which is what we're gonna be finding. So what does negative f of x mean? It means that you're gonna get f of x and multiply that f of x by -1, or just by the negative. Okay, so we put negative, that's that, we take it along, and now we're going to write f of x, which is 2x plus 3. Okay, I'm just rewriting that and getting along the negative in here. Now that I have this, I just go distributive property, and it's going to be negative times positive is negative 2x. Negative times positive is negative 3. And I'm not going to check this with this, because look at what I have. It says f of negative x has to be equals to negative f of x. So f of negative x is this answer right here, compared to negative f of x, which is this answer right here. Are they the same? No, this is the same, but then in here you have one positive and one negative. So no, it's not even, because these are not the same, and it's not odd because these are not the same. So we're going to put neither. Okay? Okay, so let's do another example. Oh, and I was going to try to do just a sketch of the graph. You can go to desmos.com, and you can actually graph this in there by putting y equals this, and you will see the type of graph that they have. But in here, this one is pretty easy to sketch. So it's the initial point is 3, and then rise is 2, and run is 1. So my graph is something like this. So as you can see, if you fold it, it's not gonna fold, they're not gonna match if you fold it like this. And if you rotate it, it's not gonna match, because look, right now the line is up here. And if I rotate it 180 degrees, the line is not up here, it's down. So that's why it's not odd either. So not even and not odd. From the next ones, I'm not going to take so much time to show you I'm just going to give you the sketch of it, okay? But you have an idea, right? It's neither, because it cannot fold in half and match, or you cannot rotate 180 degrees and match. Okay, let's do another example. So, number 2 is going to be f of x equals x squared. And so, again, the first thing is to find f of negative x. F of negative x, meaning replace every x by a negative. So it's going to be negative x to the second power. It's not x now, it's negative x. And so this means multiply whatever is inside times itself 2 times. So I'm just going to put it on the side. Negative x times negative x equals, so negative times negative is positive, and x times x is x squared. So in here, you're going to have negative x, everything squared is x, positive x squared. Do they look the same? Does my f of negative x, the answer, look like the f of x, which is yes, because both are positive x squared. So we say that this is an even function. Okay, even function meaning it has even symmetry. And so I'm just going to give you a quick sketch. Again, it's not perfect, but you can get the idea. If you go to Desmos, that's it. Now, as you can see, I didn't do the second part. If you notice that it's even, you don't have to worry about it. You're done. So now you don't have to do the other part, which is the odd. Okay, if it's even, it's not odd. Okay, so let's do number 3. For number 3, you have f of x is equals to x. And I want you to notice that I'm also using green because it's this right here. So f of negative x is equals to, instead of the x, I'm going to replace by a negative x. So basically it's just negative x, which is equals to negative x. Are they the same? is the f of negative x the same as f of x? No. So it's not even. Therefore, I have to check if the other answer gives me odd or neither. Okay, so negative f of x is equal to, in here what it says is put a negative in here, and you're going to put this in parentheses. Negative times positive is negative, and you just bring down the x. And notice that for the odd, we don't go with these two, because that's one of the questions that students had. So they compare this one, we notice that it's not even, they go to this one and they want to compare this one, but no, it says compare f of negative x to the negative f of x. Okay, what you're comparing is this one. That's why I put here as green. Okay, the green one compared to the red one. Okay, I underline those. So for the odd functions, you're comparing this one, not this one. Okay, so are they the same? Yes. That means they're equal, so it's going to be an odd function. And the graph for this here is like this. Okay? So, as you can see, if you rotate it, it does become the same graph. Okay, let's do another one. So hopefully you're getting it. If not, stick with me and maybe you'll find examples that will help you. So now this one is f of x is equal to x to the 6th plus 4 times x to the 4th plus 3x squared plus 4. Whoa, that's long. That's okay. As long as you just replace it, all the, so for the, I'm just gonna, since I don't have enough space, I'm just gonna put it down here. F of negative x means change all the x's by negative x's. It's gonna be negative x to the 6th plus 4 times negative x to the 4th plus 3 times negative x to the 2nd power plus 4. Okay? And so, for the next step, you need to understand something that you learn in Module G, that whenever you have an even, the base is negative and the exponent is even, the answer will be positive. But if it was an odd, like a 5, a 3, then the answer will be negative. So in here, let me show you why. Negative x times 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 negative x. So in here is negative times negative, positive. Positive times negative, negative. Negative times positive times negative, positive. Positive times negative, negative. And negative times negative is positive. So as you can see, it becomes positive because of pairs. The other way to do it is that you can pair this and say, okay, negative x times negative x is positive x squared, because it's 2 of them. And then in here, negative x times negative x is positive x squared, positive x squared. Okay, so when we're multiplying this, remember that in multiplication you keep the base and add the exponents. So 2 plus 2 plus 2 is 6. So 2 different ways of seeing it, but again, remember, when you have a negative base and an even, it just becomes positive. And x times x times x times x times x times x is going to be 6. So in here, again, this is going to be negative x. Since this is even, it's like if we have these two only, and it's positive and positive, it's going to be x to the 4th, right? It's going to be plus 4 times, this alone is positive x to the 4th. And then plus, I'm going to bring this 3, and this becomes positive x to the 2nd, okay? Plus 4. And so if I multiply that, this becomes x to the 6th, 4 times x to the fourth is just 4x to the fourth, 3x to the second, and 4. So now I'm going to compare these ones. Are these the same? And yes, it is. So it's even. It has even symmetry. And the graph is going to be something like this. Okay? Okay, let's do another example. So, number 5, we have f of x is equals to x to the fifth minus 4x cubed plus x. So let's do f of negative x equals, I'm changing this to negative x to the fifth. Oh, this is odd, so the answer will be negative. Minus 4 times negative x to the third plus negative x. So I'm changing every x by negative x. Okay, so in here, remember, because of negative x times negative x times negative x times negative x times negative x, this becomes positive x squared. This becomes positive x squared. But then x squared times x squared is x to the fourth times negative x is going to be equals to negative, right? Because positive times positive is positive. Positive times negative is negative, and then x to the fifth. Okay, there's a chiquitito in here. Okay, so the answer here is negative x to the fifth. Now, again, because of, we have, some people want to do negative times negative is positive 4x cubed, and no, that's not what it should be. Why? Because first you have to do the exponent in here, okay? That's what you have to work with first. So we know that we're going to bring down the negative 4 times the answer of that, and negative x to the third, again, it's like having this too, so it's only this. It's going to be negative x cubed, okay, because it's only 3, plus, oh, actually, positive times negative is negative x, okay, negative x. And so in here, we have negative x to the fifth. Let me just close this so that we don't get confused. Now that this is out, we say negative times negative is positive 4x to the third, and then this is negative x. Are they the same? This is positive negative, no. This is negative positive, no. This is positive negative, no. So I'm gonna do the negative f of x to see, because it's not even, we're gonna go to see if it's now odd. However, there is a shortcut that one of my colleagues noticed, is that now that we have, it's not even, the other way to check is, oh, are they opposite? Positive and negative, yes. Are these opposite? Negative, positive, yes. Positive, negative, yes. So if they are opposite of each other, then they automatically are going to be odd, okay? So that means by being the opposite, positive, negative, negative, positive, positive, negative, that means it's odd. But let me show you with the negative f of x, doing the steps. That means that you're multiplying negative times the original function, so negative 1 times x to the fifth, negative 4x cubed, positive x. We do distributive property, and the answer is, notice that when you have this, you can either put the 1 or not put it. It's up to you. It can be an imaginary and just multiply the signs. Or you can even just think of it, oh, I can eliminate this step and say, oh, when I multiply by a negative, all it does is change the signs in here. So it's going to be negative times positive is negative x to the fifth. Oh, the opposite of that. Negative times negative is positive 4x cubed. Oh, the opposite. And negative times positive is negative x. Oh, the opposite. Okay, so that's why it works when you say, oh, if this is not uneven, but it's the opposite, then it's going to be odd. Now notice why. These are the same, these are the same, and these are the same, so that means that it's odd. Hopefully I didn't confuse you with that. Those are just shortcuts. If you don't want to follow those, just do the 2 steps, okay? This one, you change all the x's with a negative x. For this one, all you do is get the original function, multiply by negative or negative 1, okay? And if these are the same, it's even. If not, they're not even, then you go to this one, and that's when you do, if it's not even, you do the second step. But if it's even, you don't need the second step. Okay, then you look at this. If they're the same, then it's odd. Okay, so let me sketch the more or less. This is a little bit more complex. So if you zoom in, this is going to be the graph for something like that, if you zoom in, okay, because it goes into the very decimals. Otherwise you barely see that. You cannot even see it on desmos.com, but that's about how it would look. Okay, let's do one more example. Now you have f of x equals x to the 5th plus x to the 4th, and we're going to replace all the x's by negative x, so it's going to be negative x to the 5th plus negative x to the 4th. And again, if it's an odd exponent, then it's going to be negative x to the 5th. But this is even, so it's just going to become positive, right? When it's even, positive x to the 4th. Are they the same? No, these are different signs. And again, you can do, are they opposites? Yes, this is opposite, but not this one, so it's not going to be odd either. But if you prefer to do the second step, negative f of x, it means get the original function right there and multiply it by negative. Okay, negative or negative 1 if you need to see it. All it does is change the signs of the terms. So negative times positive is negative x to the 5th. Negative times positive, negative x to the 4th. Now, are these the same? These are negative, but this is not the same sign, so no, it's neither. When you go to Desmos, the graph that is going to be created, it's a little slanted to the left. So it's something like this. It goes something like this, and then goes up like this, something like that, where you have, it goes on 2 quadrants in here, but in here it doesn't. Okay, let's do number 7. So, and you notice that you can fold it and it's not gonna match, or if you, just because of this little part and it's a little slanted to the left, you're not gonna match it when you turn it around. Okay, number 7, we have f of x equals negative x squared plus 4. And if you remember from previous lessons, this just, so you have your x squared, which is a parabola, plus 4 just moves it up 4 spaces, and then it just flips it down, like it reflects down. So let's see. Doing it mathematically or algebraically, you have f of negative x equals negative from here. Then you're going to change the x to negative x to the second power plus 4. And don't be tempted to do negative times negative because that's not how it works, okay? First you have to do this part, which is negative x times negative x becomes positive x squared. You bring down the minus because it's outside, and plus 4. Are they the same? Negative, yes. So it's gonna be an even symmetry, okay? It has, oops, oh sorry. It has even symmetry. And so my graphing here, it goes up 1, 2, 3, 4. That's my vertex, and then it's gonna open down. Okay, so you can see if you fold it, yes, it matches this with this part. Number 8. So you have f of x is equals to negative x cubed minus x. And so the f of negative x, I'm going to switch, keep this negative, but switch the x to negative x cubed minus from here, but then this x becomes negative x. Again, you don't multiply the negative times negative in here, okay? So first you do this part, which is negative x times negative x times negative x becomes negative x cubed. Now you will multiply the exponents now that you did this part. And in here, because you don't have any exponents, you just multiply. Negative times negative is positive x. Why? Because you don't have anything to work in here since there is no exponent. So we have negative times negative is positive x cubed and plus x. Now, if you remember, the shortcut of my colleague is that if they are opposites, then it's going to be odd. And you can notice that in here, positive and this is negative, they're opposites. Positive and this is negative, they're opposites, so it's going to be odd. But again, if you need to do the next part is negative f of x is equals to, this means put the negative outside and now get the original function, which is negative x cubed, negative x. And so negative times negative is positive x cubed. Negative times negative is positive x. Are they the same? Yes, so that means that this is odd. Okay, for the odd, you're comparing these two or just noticing if they are opposites. If these are the same, it's even. If they are opposites, it's odd. It has odd symmetry. So the graph for this one is actually gonna be something like this. Okay, and so basically if you rotate it, this goes up here and this goes down here. Look how it's up on the left. So notice how that is up on the left. Okay, so it is odd. And so I think I'm going to stop here, but then you're going to come back to another part of it, and now you can work on part most actually of 5.4. See you soon.